Okay, now we're going to test the electrode on the Gauss meter. So this is just a ferrite magnet, and when you go this way, needle moves up, you flip over the magnet, the needle moves down. Okay, so first we're going to put the meter down, and we're going to take the magnet and watch this. Okay, sticks right there. Now we're going to flip over the magnet. And it sticks right there. Come this way. It sticks right there. But it won't stick there. Flip over the magnet. And it won't stick there. Okay? But it'll stick here on the light side. Each time. Now watch. Take the Gauss meter and I'm pushing it on this side of the electrode. I'm just going to go in and out. I can't do two things at once. As I go in, the needle goes down. Okay? Not so surprising. However, I'm going to flip over the electrode. Now watch the needle. Okay? As I get closer, the needle goes up. As I come to the quarter part, right in the middle, the needle goes up. When I'm here, and when I switch to the fourth pole, the needle goes up over here on this pole. Right here. Showing you the 4 poles of gravity. Okay? Over magnetism. It's been hidden the entire time. The fascinating part of it, it's about 109 degrees off of magnetic north to 130 degrees. 115 to 130, right around there, if you watch my gravity videos. Okay? So that's why when they're looking from space and gravity, it's hidden behind the magnetic field because you're using the wrong sensor, NASA. Now you have to come to me because I have the sensor to test this. This is just a little bit of an introduction to what I know. Okay? Now let's look at the other side of the electrode. This is to be expected. There is no Gauss, except when you get to the middle. In the middle of the electrode, I'm down, but I should be up, as for what you just saw. So the magnetic field is going into a helix into the end. This is the gravity end. This is the magnetic field end. So let's go back over here to the granite block one more time. You see that? Every time. Every time. Magnetizes to Earth. I guess we're going to have to say now, this has been Ripple Talk Radio, because what we're going to do next is this. Are you ready? I'm going to disclose this because I've threatened this for years. Now we're going to set it up today. And this is what we're going to do. This is how I'm going to send my resume to JPL Labs. The rover, I have to tell the story. I was at the JPL in the QC room, and they were testing the rover wheels. They machined the billet tread out of a big block of aluminum. Then they machined the spokes out of titanium number 2. As they were machining the titanium in cutting, I picked up a piece of number 2 stainless. It was a whatnot at the machine shop side of NASA. And I banged that piece of titanium, and I kept on chiming it to get it to resonate, and it talked to the piece of titanium that was on the lathe being cut, and the exact squeal imposed on the piece I was holding in my hand. And I said, "Do you see that, NASA?" "That's right." And they went, "Oh, that's impressive. You're welcome." So what we're going to do is we're going to set up an attenuation, and we're going to use an apparatus. And that apparatus is going to fire at the speed of light, a radio frequency, to the wheels that are on the rover, because the rover is, that's how they communicate to the rover. The wheels are the antennae to the rover. Now, I can, because I'm more powerful, potentially drop a G code on the rover and steer it, but we're not going to go there because of this subject. When they first made the wheels for the rover, they had JPL in the tread, and NASA was not going to have JPL tagging Mars with JPL. So they redesigned these $250,000 wheels each, okay, to tell them that, okay, now we have these holes in the tread, but these holes are to tell you if you're going to go through softer, hard soil. And so NASA bought that bullshit, okay? When the wheel got on the rover, by the time it was already on the launch pad, NASA figured out that the new holes in the wheel are Morse code for JPL. That's a true story. Okay? I heard it from the man out of his mouth, looking me in the eye, that made that happen in the QC department of the machining of those wheels. Okay? Chuck. That's all you need to know. His name is Chuck. He knows who he is. Okay? So this is what we're going to do. I'm going to ping those wheels with a capacitive discharge of the oscilloscope shots that I just gave you during the intermission of the ripple. You were just watching a radio frequency matched with the speed of gravity, 33 times the mass of gravity. And this electrode just proved that to you. When I put this electrode back in there, don't be surprised what it'll do. I know what it'll do. Okay? So I'm going to ping those wheels in Morse code. Okay? But I don't know Morse code. So that was the first idea. My friend who sets up concerts for rock stars is on his way over with a synthesizer, an equalizer, an amplifier, and we're going to go deadhead into this attenuating device. And I'm going to talk into those wheels. And they're going to end up on Mars at the speed of light. Okay? They take NASA right now 9 hours to send a radio signal to change one little G code so that little rover can go dit, 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 and then 9 hours to send the radio frequency back so that it can tell them that I heard you guys. I'll go ahead and change direction. Click. Dit, 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 dit. If they're not careful, I'm going to go to Google Earth and Google Mars, and I'm going to GPS a G code for the rover, and my signal will be stronger than theirs. So I hope Ron Aguilar from JPL Labs, who was the encrypted code writer for the Scalini missions and all these guys, he's now retired. I hope he did a very good job patching the rover, because I'm going to, if that works, hypothetically, I told you all, if I say something that I don't know, it's hypothetical because I may be wrong, but let's just take a chance and say that I'm right, okay? And they don't hear me on the radio frequency, and I can change the direction of the rover, because I'm sure they're not really worried about anybody changing the direction of the rover because, well, for all kinds of reasons. Let's just hypothetically think that I can bump through their code and let the rover take my G code from GPS. I'll write my name in the sand of Mars and my phone number. And I might as well just put www.protonspintechnology.com just to make sure they know who sent the signal. This is the problem, okay? I could possibly be in some serious trouble for this, but I'm going to do it anyway, just to see what'll happen. But first, I'm going to ping that, and they're going to feel that I guarantee you that the rover has got vibration sensors, because the wheels that they make on the rover are these extremely sophisticated spoke shock things that are like two horseshoes in a quasi S turn. Okay, they're very an interesting angle, and they explain the angle to me and what they do so they know if they're going over something solid, not just the holes. So if they hit something, it will send a vibration back to the rover, and they know if they hit something super solid or just kind of solid, so they can make a decision if they want to go over it or around it. They're pretty sophisticated. So that means that the vibration of the wheel, I guarantee you they will hear that Morse code, because I'm going to send it in a high capacitive discharge over laser. It's going to vibrate those wheels. They're not going to have a choice but to listen to me. Enjoy your day. This has been Ripple Talk Radio.